Okay, so what we're going to do, guys, is heads up, Unit 2, Worksheet 5. This is where we're going to practice going from different representations of motion, different models, to other models. Heads up. Heads up.
My heads are up.
After this worksheet, oh no, review sheet.
Oh, who is review sheet?
So if you notice that there are things as we go through this that don't quite make sense to you, please feel free to ask questions about them. And it's a good idea to do them, because if we can straighten those things out before the review sheet, then yay. So this is the last bit of practice we have before we review for our unit test. All right, so we've already talked a little bit how once we've collected data, there's different ways that we can represent it, and we can create different types of models. And so each of these things is a different model that describes motion. We've got a position versus time graph, a velocity versus time graph, a written description, and a motion map. And the way this worksheet works, we're going to be given one, and then we have to figure out the other three based on the one, because they all come from the same data. So here with the first one, I'm just going to take a look at this and describe a little bit, because I find that that helps me to be able to think through what I'm looking at. We know that on our worksheet, we're expecting to see constant velocity. So we should either have a constant positive velocity, a constant negative velocity, or a velocity of 0, which is constant. All right, so if I take a look at this, the motion of this object happens in 3 parts. First part, second part, third part, right? 1, 2, 3. In this first part, we've got a constant velocity, which we know because it has a constant slope, and that slope is positive. Do you guys see that? Because it's moving upwards. So I'm going to write velocity equals, and then I'm going to write a plus sign for positive and constant. I like to just jot, I know that they're all going to be constant. I like to get in the practice of jotting that down, because in our next unit, they're not always going to be constant. In the second chunk here, the second part of the motion, my object is not changing position at all. And because I understand how that works, right? If I'm not changing position, I'm not moving. If I'm not moving, I don't have any velocity. So my velocity there is 0. That one's pretty easy. Then in the last part, now instead I have a negative slope. So I know that my velocity is going to be negative, and it's still constant. And we can even add a little bit more detail here. We can tell that the distance traveled, it looks like about the same amount of time as the first chunk, but the distance is about twice as much. So we know that the magnitude of this has to be about twice the magnitude of this one. It's much faster. Opposite direction, but faster. All right, so I like to draw my velocity versus time graph just over time. I've gotten really good at thinking about moving from position versus time to velocity versus time and back. So we already said velocity is 0 for the second one, so I'm just going to draw a line right there on my axis, and I'm going to label that 0. Go up is positive, down is negative. So if I have a positive constant velocity, I'm going to have a horizontal line for my velocity versus time graph, and it's going to be in the positive part. So I'm just going to draw a line there. And remember, you don't need to connect these ends. Like if you actually draw a line there, it implies that you think that at that point in time, your object has every possible velocity between those 2 points, which is not possible. Then for this third chunk of time, we've got a negative velocity, so it's going to be in the bottom part of our graph. And we also said that it had a larger magnitude than the first one. So that means that if I look at this distance, the distance to my line in the third part is going to be lower. There. All right, so now we got those two. Written description. We're going to need to write something about when the object starts. We're going to need to write something about where the object stops. And then we've got some motion in between, right? We've got those 3 chunks in between. So what can we say about the start? Does it start at 0?
No.
No, it starts at a positive position though, right? We don't even have a value for that. So I'm just going to say my object starts at a positive position. There's lots of ways that you can write this and it'd be okay. The object starts away from the origin. The object starts somewhere that's not 0. There's lots of things you can say and be right there. For the first part of the motion then, I'm going to say my object moves with constant positive velocity. I don't know about you guys. I like to abbreviate my words. As long as I can tell what you're trying to say, that's fine. What about the next one? What's the object doing?
Motionless.
Yeah, either of those are fine. So you could say object is motionless, object stops moving, object has velocity equal to 0, any of those things. No change in position. Oh, sorry, that might be hard to read. No change in position. I think the most significant thing that happens with that third part of the motion is the object is actually turning around. It's going the opposite direction, right? So there's different ways you can say that. If up here you said it was moving with a positive velocity, if down here in the third part you say it's moving with a negative velocity, that tells you that there's a change in direction. You could say it explicitly. You could say object changes direction and moves with a faster speed. Oops, faster speed. Right? Speed doesn't care about what direction we're going. Speed is just the magnitude of the velocity. And lastly, object comes to a stop. Do we know where? It's between the origin and where it started, right? I mean, what could I say about that? I'm going to say at a more... I'm not going to say it that way. I'm going to say closer to 0 meters than it started. Is that okay? So then there's the motion map. How do you guys feel about motion maps? Yeah, that's how people feel about motion maps. All right, I'm gonna try to give you a tip of a different way to approach the motion map. Okay, here's a different way to approach motion map. If you take a look at this time down here, I hope that you guys have noticed that there's these dashed lines, and that's meant to indicate points where you're at the same time on both graphs, right? Same time, same time. So I'm going to take a look up here because a motion map is more closely tied to my position versus time graph. And I'm going to divide this up into little pieces. And this looks like this is about the same as this, and this is about the same as this. So they are about the same amount of time. But I also want to capture that motion by putting a point in between them. So I've divided them into equal units of time. I don't know if it's a full second. I'm just going to pretend that it is. Next, what I'm going to do is indicate where on my line each of those times would be represented. So I'm just going to put dots on my line. Like that. So there's my dots. What I'm going to do is I'm going to project this graph where these dots are on the side here because this is position and this is position. And so if I draw it over here, if I project it over to the side, I can just rotate it down and draw the motion map. Sam?
Are we allowed to just do the points at like the farthest left and then the dotted line and then the next dotted line in the end rather than have one in between?
it's kind of nice to have those inflection points represented.
Okay.
So I would personally put those in there. Okay, so what I'm going to do is I'm going to kind of project these aside. This dot I'm going to draw over here. This one over here. This one there. And then I've got a couple dots, right? So I'm going to draw those. And then I have another dot. And then my last dot. You guys see that? I just copied them over. And if I put arrows in here, it starts to look a lot like a motion map. So then I'm going to take this and I'm going to rotate it and put it down here. All right, so if I do it like that, that looks like a motion map, right? Do you guys see it? So over here, I'm going to label this 0. And my first dot is kind of, sorry, my first dot is kind of far away, so I'm going to put it over here. So I don't know what the actual measurements are. And I need 3 dots that are going in the positive direction. And then my object stops moving for 2 seconds. My estimated 2 seconds. My 2 units of time. How about that? Then it comes back, and I can tell that my first dot is going to be closer to 0. Sorry, this dot is going to be closer to 0 than my first dot was. Get my arrows. So I put these so that it's really clear where my motion started. All right, what questions do you guys have? Sam.
So for that T=6, like that arrow,
This one?
do you need to put an arrow on that one because you don't know if it stops after that one?
Yeah, that's debatable. You can if you want to. Or if you don't do it, that's okay too. The other thing that's really interesting too about this, you guys see how these are short and these are long? The first 2 are short arrows, the 3 at the bottom are longer arrows. If I take these 2 arrows, watch this, I can put them over here. And then there's no arrows here, right? They have a length of 0. And then down at the bottom, I have longer arrows. So that your motion map agrees with your velocity versus time graph. You don't have to draw those arrows there. I'm just drawing them there so you can see that. Okay, any other questions about number 1? No? Okay. So second one, I'm just gonna show you guys the part where we go from velocity versus time to position versus time graphs. Again, we've got those dashed lines that tell us about what's happening at different points. The easiest thing to do is look and see if you have any places where your velocity is 0. Here our velocity is 0, so that tells us that at that point, we're gonna have a horizontal line because the position's not changing. So we're gonna write position is constant, it doesn't change. All right, what can we get from this first part of the graph? What do we know? Is our velocity positive, negative, or 0? Yeah, our velocity is negative. That's right, velocity is negative. What about this one? Positive, negative, or 0? Positive. Which one's bigger? The first one or the second one? The first one. The first one's going to be steeper than the second one. What's the opposite of steeper? Shallow? Less steep? All right, so then when I go to draw my position versus time graph, do I know where my object started? I don't know that. My velocity versus time doesn't tell me where it was. It just tells me how its position changed. So I can start anywhere in here, but I know that I need a pretty steep negative sloped line, right? So I'm going to need something like this. So if I started at 0, I would have to draw a line that goes down into this. And honestly, that would just be messy, right? I'm going to start farther up here. I'm going to draw a steepish line with a negative slope. It's okay if it's not perfectly straight. And then I need to draw a less steep line with a positive slope. So now I'm going to draw a line that moves in the positive direction that has increasing value, right? But I'm not going to go as high as I started. It has to be less steep. So I'm going to draw, it helps me if I know where I'm drawing to. I'm going to draw a line like that. And then at the end, my velocity is 0, my position doesn't change. So I'm going to do my best to draw a horizontal line across here. So that's how I would go from velocity versus time to position versus time. So what I'd like you to do with the time that we have left is finish up problem number 2. And then on the other side, just do 3 and 4. That's just going to be our goal for today. Do you guys have any questions for me? Yeah.
On 4, on the one that you did so well, how did you connect it from
the vertical lines? I don't know. You don't really need to do that. Just think about it like it's like this. Just the horizontal parts.
Okay.
Yep. Any other questions? All right, I'm going to let you guys go ahead and get started. It's kind of interesting. We're missing like one person from tables and not 2 people.